Okay, here we want to look at a linear equation, a system of linear equations, but instead of using the traditional elimination method or substitution method, we're going to use the inverse of a matrix to solve it. So we have 2x minus y is equal to negative 1, and 2x plus y is equal to negative 3. All right. So the first thing we want to do, we want to create our coefficient matrix. So let's let that be equal to A, and we're going to have 2, negative 1, 2, and 1. That comes from the coefficients of x and y, respectively. Okay, so now we need to find the inverse of the matrix. Now, remember how we found the inverse, 1 over the determinant? So in this case, that is 1 over 2 minus a negative 2. 2 minus a negative 2, it gives us a 4. And remember, we needed to switch the positions on the main diagonal here. So instead of 2, 1, that's 1, 2. And we need to negate the remaining number. So instead of negative 1, it was 1. And instead of positive 2, it was negative 2. We may have to go back and review that, and that's no problem. Okay, so to finish this problem up, remember we have to say 1/4 times 1 is 1/4. 1/4 times 1 is 1/4. 1/4 times negative 2 is a negative 2/4, which reduces to negative 1/2. And 1/4 times 2 is 2/4, which is negative 1/2 again. And that was just scalar multiplication, multiplying the scalar 1/4 by our matrix. So now what we do, we have the inverse of our matrix. But in this case, we have to multiply it by the solution vector, which was negative 1 and negative 3. Okay, so let's go right here. We've got 1/4 times negative 1, which was, we're going to show every step, negative 1/4. 1/4 times negative 3 was negative 3/4. Okay, and for our next line, we have negative 1/2 minus 1 times negative 1, which is 1/2. And then 1/2 times a negative 3, which is a negative 3/2. So we can easily just solve this problem. Negative 1/4 minus 3/4 gives us a negative 4/4, which is a negative 1. 1/2 minus 3/2 is a negative 2/2, which also gives us a negative 1. All right, so our answer for x and y is negative 1 and negative 1. So we could easily plug this back in and check it. So let's go. 2 times negative 1 is negative 2 minus a negative 1. That's correct. That will give us a negative 1. 2 times negative 1 is negative 2. And negative 2 minus 1 will give us a negative 3. So it checks back out. And that's just an example of how we can use the inverse of a matrix to solve a system of linear equations as well. This does work with 3x3s and 4x4s. It's probably not as efficient because it would be better to use the traditional elementary row operations. All right, but this is just another method that we can use in lieu of the elimination method and the substitution method.